Hello, we are going to determine the inverse Laplace transform of the given function. This function here is a rational function, and in order to find the inverse Laplace transform, we need to rewrite this by using partial fraction expansion. So that's part of the things that we need to do when we're finding inverse Laplace transform. Not always, but often we need to do that. So let's charge ahead here. What do we have in the denominator? We have a linear term, s plus 2. And so for our partial fraction expansion, we write a over s plus 2. And then the next term is a quadratic that's irreducible. It doesn't factor over the real numbers. And so for that, we put s squared plus 9 in the denominator, but we write bs plus c. So we have that, and then we clear the fraction, and so we'll write negative 5s minus 36 equals a, s squared plus 9 plus b, s plus c, s plus 2. So I'm sort of crowding, and that's not a really good thing to do. I guess maybe I'm doing that because I feel like I don't have as much space as I want. I'll just move this down here. Okay. So we have this, and what I'm going to do is I'm going to pick values of s that will cancel some of the terms. Our unknowns here are a, b, and c. So if you do these more often, then you start getting into the swing of things. This s plus 2 can be made 0 by setting s equals negative 2. The equation that I just wrote is, we want it to be it's supposed to be, it is valid for all values of s. Even though s equals negative 2 right here would make 0 in the denominator. But anyway, we put in s equals negative 2, and this is going to clear this. And the challenge is to somehow focus and not make little mistakes. Or big mistakes, okay? So see this this negative 2 plus 2 makes 0 here. On the left-hand side, we have 10 minus 36 equals a, 4 plus 9 plus 0. So negative 26 equals 13a. So a is equal to negative 2. So we get that. And then, so what we do is we use that a is equal to negative 2. And let's go ahead. And what I do is I put that into this equation with a is negative 2 right there. So I can rewrite that as negative 5s minus 36, negative 2, s squared plus 9, plus bs plus c, s plus 2. And so now what I can do is I can't use negative 2 again. That wouldn't really help. But I can put s equals 0. S equals 0 will kill the b term. So see, now we only have c and b to solve because a is already negative 2, we decided. So putting s equals 0 will make that b term disappear, and we can get c. So we put s equals 0, and so the left-hand side let's put in s equals 0. So we have negative 5 times 0 minus 36 equals negative 2, 0 squared plus 9, plus b times 0 plus c. Zero plus 2. So I get negative 36 equals negative 2 times 9 is negative 18, plus c times 2. So negative 18 equals 2c, and that implies that c equals negative 9. So now I can use that and plug that in to what I had. I had negative 5s minus 36. So what I mean is going over here. That's what I'm looking at. I'll put a as negative 2, and I'll put c as negative 9. So negative 5x minus 32 equals a, which is negative 2, s squared plus 9 plus bs minus 9s plus 2. And now I don't really have a really special number to put in like negative 2 or 0, but I can just put in s equals 1 because now b is our only unknown. So putting in s equals 1 makes negative 5 minus 36 equals negative 2. 1 squared plus 9 plus b times 1 minus 9, 1 plus 2. So there's nothing special about 1. It's just I need to put something in there. I thought, oh, when I put 1, maybe someone else will put in negative 1 or 3 or whatever might do the job. This is 10, so this is going to make negative 20 plus b minus 9 times 3. So this will make negative 21 equals 3b minus 27. So that's going to give 6 equals 3b. So therefore b is going to equal 2. And, it's a bit of work, right? It definitely is. So therefore f of s is equal to a, which is negative 2 over s plus 2 plus bs plus c. And bs plus c is 2s minus 9 over s squared plus 9. So maybe I'll start a new page here. So what are we doing here for this part here? Well, okay. So we're trying to find the inverse Laplace transform. So we have formulas that we will use. So, all right, we know, hopefully, or somewhere along the way, that the Laplace transform of e to the as, not as, at is equal to 1 over s minus a. The Laplace transform of sine bt is equal to b over s squared plus b squared. Laplace transform of cosine bt is equal to s over s squared plus b squared. So we're sort of getting somewhere on this. So f of s can be written as negative 2 times 1 over s plus 2. So we get that part out of the way. And then we have 2s s squared plus 3 squared. Okay, that looks like it's going to be set up for the cosine. And then minus 9 s squared plus 3 squared. Well, we need a 3 in the numerator because I need b over s squared plus b squared. I need b there. So I just introduced a 3, and then what I can do when I introduce that is divide by 3. I mean, it's the same thing as if you factor 9 into 3 times 3 and leave a 3 up there. The same result. So then f of t will be negative 2 e to the negative 2t plus 2 cosine 3t minus 3 sine 3t. Oh my goodness. All right. So, I guess I'll just stop there and then do the second problem in another video. Okay.